Hello everyone, I welcome you all to the online classes. Students, today we are going to start with chapter 10 of class 9th physics, that is gravitation. So let's start with the chapter. Before starting with the chapter, we should know the aims and objective of this chapter. The aims and objective of this chapter are, students, you will be able to state the universal law of gravitation and enlist its application. Also, you can be able to derive the formula and thus calculate the value of acceleration due to gravity on the surface of Earth. Next, you can easily differentiate between small g and capital G, and lastly, you will be able to solve the numericals based on the concept of mass and weight. So let's start with the video. Now, topics to be discussed in this video are gravitational force or gravity, universal law of gravitation. Next comes properties of gravitational force. After that, universal gravitational constant. Then comes free fall. After that, acceleration due to gravity. Then equations of vertical motion, and lastly mass and weight. So let's start with the video. I have divided this chapter into 3 sessions. So in the first session, we are going to start with universal law of gravitation, and after every session you will be having summary and check your understanding portion. What you are going to do is, in check your understanding question, you are going to attempt those questions. If you face any difficulty, pause the video and replay till you get the concept. So let's start with session 1. In this session, we will be discussing till universal law of gravitation. So let's start with the session. Before starting with universal law, we should know what do you mean by gravitational force of Earth or gravity. As we know, force is very necessary to produce motion. So whenever a body is dropped from a height, we observe that it always falls towards the earth. That means that earth exerts a force of attraction. This force of attraction is called your gravity. And remember that earth attracts all the object towards its center. Fine. So the force of attraction by the earth is called gravity. Now, what gravitational force is responsible for? It is responsible for holding the atmosphere above the earth, for bringing rains, for flowing of water, for keeping us firmly on the earth, for revolution of moon around earth, and many more. So let us discuss about universal law of gravitation. Newton's universal law of gravitation states that every object in this universe attracts every other object or body with a force that is directly proportional to product of their masses and inversely proportional to the square of distance between them. What do you mean by this? So Newton stated that force of attraction between two objects, and remember this force of attraction is acting between every two objects, is directly proportional to product of the masses of two objects, where m1 is the mass of first object and m2 is the mass of second object, and it is inversely proportional to the square of distance between them. Inversely proportional to the square of distance between them, where r is the distance between two objects. Suppose this is first object and this is second object. They are separated by a distance r. In some books, it is the distance r is also written as the distance d, or abbreviated as distance d. So there is no issue to be created over this. It's okay with that. So force of attraction is directly proportional to the product of masses and inversely proportional to the square of distance between these two masses. Now what I mean by this is, that even your book and your pen, if these are two objects, they are having the force of attraction. This force of attraction depends on the product of the masses of these two objects, that is book and pen. Fine, not on one object. It depends on the product. Product means multiplication. Fine, so product of masses on the of these two objects and is inversely proportional to square of distance between them. By square of distance, I mean that the distance between square of the distance between these two objects. So let us discuss what Newton said. As you can see, this is first object, this is second object, separated by, as I told you, in some books it's written as D, or in many other it is written as R. So no confusion has to be created. Whatever you are using, use it till the end. So this is a simple diagrammatic representation of universal law of gravitation. Now let us proceed further. Many of you would be thinking, what do you mean by directly proportional and what do you mean by inversely proportional? First of all, we should know this is the sign for proportionality, that is, we make it like this. What I mean by directly proportional? That means that if more is the product of masses, more is the product of masses, more is the force of attraction. Fine. So directly proportional means if one increases, another entity also increases. That means if here the product of masses are more, the force of attraction will also be more. Now what I mean by inversely proportional, which Newton said that force is inversely proportional to square of distance between them. By inversely proportional, I mean the more is the distance between two objects, the less will be the force of attraction. That means inversely proportional means if more is the distance, then less is the force of attraction. This kind of relationship is called inversely proportional. So universal law of gravitation states that force of attraction between two objects is directly proportional to the product of masses and inversely proportional to the square of distance between them, as it is written. Now let us proceed further. If we will combine, F is directly proportional to m1 into m2, not on the product, not on one mass. It is dependent, that is, the force of attraction is dependent on the product of two mass and it is inversely proportional to the square of distance between them. What I mean by square of distance between them, F is inversely proportional to square of distance between them. Now combining 1 and 2. If I will combine 1 and 2, then I will get F is directly proportional to m1 into m2 by r square. Now when I will convert this proportionality sign, that means this proportionality into equal to, then I have to bring a constant. This constant is called capital G, which is also called universal gravitational constant. Universal gravitational constant. Fine. So the formula for universal, that is force of attraction, is F is equal to capital G into m1 into m2 by r square, where capital G is universal gravitational constant. Hope that this concept is very clear to you. Now let us proceed further. So what are the properties of gravitational force? First of all, as I told you, it is the weakest force. Secondly, it is attractive force. That means it is not a repulsive force. Next, it is a mutual force. What do you mean by mutual force? Suppose this is first object and this is second object. If first object is applying force on second object, then second force will also apply equal force on first object. That is why we are calling it as mutual force. Both the objects will apply equal force on each other. Next, it is a central force, that means it acts along the line joining the centers of two bodies. Lastly, it is mass and distance dependent, that I had already explained you further. Now let us proceed further. What is universal gravitational constant? We had already discussed about universal gravitational constant. The value for universal gravitational constant is 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square, and this value has been experimentally calculated. You need to learn this value, that is the value for universal gravitational constant is 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square. Fine, so you can write it anyway. The value of capital G, that is universal gravitational constant, is same throughout the universe, and hence the name. Its value is same, it can never change. Its SI unit is Newton meter square per kilogram square. How will you define this universal gravitational constant? Actually, the formula for force of attraction is F is equal to capital G m1 into m2 by r square. Now, if I put the value of m1 and m2 as 1 kgs and r is equal to 1 meter, so r square is equal to 1 meter square. So let us, what I am saying is, I am writing F is equals to capital G, m1 is 1 kg, m2 is also 1 kg, and r becomes your 1 meter. So r square becomes 1 meter square. So in this case, F will become equal to G, capital G. That means force of attraction will become equal to universal gravitational constant when your mass of both object is 1 kilogram and the distance between them will become 1 meter. In that case, force of attraction will become equal to universal gravitational constant, and this is how it is defined. So how we will define universal gravitational constant? It is defined as numerically equal to the force of gravitation which exists between two objects of unit masses kept by a unit distance from each other. Unit means 1. So they are of unit masses, that means they are of 1 kgs and separated by unit distance, that means separated by 1 meter of distance. So 1 here r square gives you 1 meter square. So this is how your universal gravitational constant is defined. Now, how the formula for universal gravitational constant is derived? So again, we are going to have that only, that force of attraction F is equal to capital G m1 m2 by r square. Now I would be rearranging this formula, and I know my students are smartest to rearrange. So what I will do is, I will bring this r square on LHS side. Here on RHS it is in divide, on LHS it will be just multiplied with force of attraction. So F into r square is equal to capital G m1 into m2. Now m1 and m2 are in multiplication with capital G. When I will bring it to LHS, it will convert into division. So FR square divided by m1 into m2 is equal to capital G, that is universal gravitational constant. So here it comes with this formula only. Capital G is equal to F into R square upon m1 into m2, as I discussed and explained you here. Hope that universal gravitational constant is clear to all of you. Now, what is the importance of universal law of gravitation? It is the only force that binds us to the earth. It is the force which brings about motion of moon around the earth. It is the force that produces motion of planets around the sun and the tides due to moon and sun. Thank you students for watching this video. We are going to continue this session further.